Hello all, welcome to my channel Codify with Sonal. Today we are going to do this part 4 of the series AWS Solution Architect Associate Practice Series. So this is the second practice series that we are doing on AWS Solution Architect Associate. So there is already one practice series and 3 parts of this practice series on my channel. Please check that out. The links are in the description box below. So first of all, rules to follow to excel your exam. Okay, make a group of study mates. It becomes easy if you have study mates along with you, with whom you can study. Like if you like group study. Okay, so divide the services and prepare individually. Some can prepare on storage, some can prepare on compute. Okay, and plan the test for each other so that you concentrate on each other's weak points and make it strong from your end. So it's like helping and excelling together. Okay, and have good understanding before this practice series. That is because I always tell you, I am not sharing dumps. Okay, don't treat this as dumps. These are practice questions which helps you understand the service and how you are supposed to make two services combination, how it works, and how are you supposed to think for your exam. So let's start. Multiple choice questions. There's no negative marking, so do give answer. Do not go ahead without marking. Even if you think you will review it later, trust me guys, you will not get time, because the questions are so big that at least you need to read the question twice. So to read the question, some 8 to 10 lines of question, you need some time, and you have very less time for your exam left after you're done all the questions. So if you have read it once, mark it for review. I'm not saying no to mark it for review, but select the answer and mark. Why? Because in case you do not get time to review, what will happen is if your selected answer was correct, you will get the marks for it. Correct? So this was the homework question, which was given in part 3 of the series. Okay, so we'll start with this. A video production company is planning to move some of its workloads to the AWS cloud. The company will require around 5 TB of storage for video processing with the maximum possible I/O performance. They also require over 400 TB of extremely durable storage of storing video files and 800 TB of storage for long-term archival. Did you say long-term archival? Which combination of the services should a solution architect use to meet this requirement? Okay, so the best I/O performance can be achieved by using instant store volumes for the video processing. Okay, so now where do you see instant store? B and C. So you can easily eradicate A and D. This is the way to eradicate the answers. Okay, but do not forget to read the left out answers so that you should also know why this is not correct. Okay, so coming to instant store, so you have EC2 instant store for maximum performance, EC2 instant store for maximum performance, correct. And then they say that you need a good durable storage, right? So durability, in terms of durability, S3 is the best. It's 11 nines, right? So you get 11 nines percentage of durability, and for archival, Glacier is the best. So the correct answer is Amazon EC2 Instant Store for maximum performance, Amazon S3 for durable data storage, and S3 for Glacier for archival. Okay. So now why others are not correct is, first thing here, S3 for durable data storage and S3 Glacier is correct. Why not EBS? Okay. So why not EBS is because EBS is not going to provide you as much IO performance as an instant store. That's the, like, it can provide but not the maximum IO as they want according to the requirement. So instant store is a better option. Okay. Next, why this is not correct is because they are using EFS, and we need we need durability for storing video files. So S3 will give you more durability comparative to EFS, and EFS will not be that cost effective also. You will always advise your clients to get cost effective solutions, correct? And now EBS for maximum, we have already discussed this, that this is wrong. Okay. Coming to start of today's questions. An AWS organization has an organization unit, OU is organization unit, with multiple member accounts in it. The company needs to restrict the ability to launch only specific EC2 instance types. How can this policy be applied across the accounts with the least effort? So there's an organization and it has multiple member accounts in it. Okay, and the company needs to restrict because every EC2 type of law instances will have some values, right? Like some cost things and the storage things, all the configurations. So the organization wants to use only one specific EC2 instance type, so that no other member, because there are multiple members, no other member should be able to create any other type of EC2 instance. This is the question. Okay, so now what can you do in this scenario? Now, to apply the restrictions when you have multiple member accounts, what do you use? You use a service control policy in AWS organization, that is SCP. Okay, now how do you do this? You create a deny rule in it, and that applies to anything that does not equal the specific instance type you want to allow. Like you can just deny it. Okay, so the correct answer to this is create an SCP with a deny rule that denies all but the specific instant types are allowed. Okay, so let's see why others are not correct. Now with allow rule, SCP with allow rule, why not with allow rule? Why? Because deny rule is required here, not allow. Next, create an IAM policy to deny launching all but the specific instances. That is incorrect. Why? Because with IAM you need to apply the policy within each account rather than centrally. So with this you'll require much more effort. Okay, now using resource access manager to control which launch types can be used. Now this is also incorrect because RAM is a service that enables you to easily and securely share AWS resources with any AWS account or within your organization. It is not used for restricting access or permissions. So SCP with deny rule is the correct answer. Next question. A solution architect is designing the infrastructure to run an application on Amazon EC2 instances. The application requires high availability and must dynamically scale based on demand to be cost efficient. What should the solution architect do to meet these requirements? What is it asking is, there's a solution architect who is designing the infrastructure to run an application, okay, on EC2 instances. Now the application requires high availability. Now first of all, what do you mean by high availability? We have discussed it in many videos. It's like having your instances in more than one AZ is high availability. If one AZ goes down, you have your instances in the second AZ as well. And dynamically scale based on demand comes up to auto scaling. Okay, so think the words in your mind when you see high availability, more than one AZ. When you see dynamically scaling, you are talking about auto scaling when it comes to the perspective of EC2. Okay, so now how are we supposed to design these? So as these are applications, okay, so we should use here is application load balancer. What will happen? All the incoming connections can be distributed to the instances by using an application load balancer. Okay, so and already we have to use an auto scaling group. As I told you, you need to have dynamic demand ready. So for that you need auto scaling group. Okay, so what will happen? There will be an application load balancer which you will configure in front of auto scaling group to deploy the instances to multiple AZ. Okay, and this is the similar thing given here. As I said, we'll be using application load balancer. You are already eradicating 2 points. Okay, so application load balancer in front of an auto scaling group to deploy instances to multiple regions. Here, regions. We don't want to deploy to multiple regions. We need high availability. Okay, so we need to deploy it to multiple availability zones. Okay, so D is the correct answer, but let's see why others are not correct. Configure an Amazon API gateway API in front of an auto-scaling group to deploy instances to the multi-AZ. Okay, deploy instances to the multi-AZ is correct, but why not API gateway? Because API gateway is not used for load balancing. Okay, and application load balance, I told you we don't need to do it to multiple regions, we need multiple AZs. CloudFront distribution, why not that? Because you cannot launch instances in multiple regions from a single auto-scaling group. So, application load balancer in front of auto-scaling group to deploy instances to multiple AZ. Next question, a company provides a REST-based interface to an application that allows a partner company to send data in near real time. The application then processes the data that is received and stores it for a later analysis. The application runs on EC2 instances. The partner company has received many 503 service unavailable errors when sending data to the application, and the compute capacity reaches its limits and is unable to process requests when spikes in data volume occur. Okay, which design should a solution architect implement to improve scalability? So basically, there's a REST based interface which is sending near real time data to the application. The application like it consumes the data and then it saves it and stores it for later analysis. Okay, but the company is receiving 503 service unavailable errors. Now they want to improve the scalability. So how are we supposed to implement scalability here? I would say Amazon Kinesis enables you to ingest, buffer, and process the streaming data in real time. Okay, for data ingestion, that would be a good solution, but to ensure the compute layer can scale to process increasing workloads, EC2 instances can be replaced by Lambda functions because it is REST based, right? So we can have easily Lambda functions and we can use it. So the correct answer here would be use Amazon Kinesis data streams to ingest the data, process the data using AWS Lambda functions. Process the data using AWS Lambda functions. Let's see why others are not correct. Use Amazon SNS to ingest the data and trigger the Lambda functions to process the data in near real time. First of all, SNS is not a near real time solution for data ingestion. SNS is used for sending notifications. Here itself, it's wrong. Use SQS to ingest the data. Configure the EC2 instances to process messages from the SQS queue. Same thing. For real-time data, we use Kinesis data streams, not SQS. Next, if I not API gateway in front of the existing application, create a usage plan and quota limit. Why not API gateway is because in front of the existing application, a usage will limit the amount of data that is received and cause more errors to be received. Okay, like if you limit the data amount, what will happen? You keep on receiving more errors rather than decreasing the error and improving the scalability. So to do that, we need Kinesis data stream to ingest the data because it is a real-time data, and process data you use Lambda functions. Okay. Next question, a company has two accounts for performing testing and each account has a single VPC, VPC test 1, VPC test 2. Okay, two accounts, two VPCs, one in each. The operation team require a method of security copying files between EC2 instances in these VPCs. The connectivity should not have a single point of failure or bandwidth constraints. Okay. Which solution should the solution architect implement? Now, here they are talking about there should not be any single point of failure as well as no bandwidth constraints that should come in between. So, best is if you have if you have two accounts and it is inside AWS and you are you're going to transfer some data between those VPCs. The VPC peering is the correct solution. So what is VPC peering connection? It is a networking connection between two VPCs that enable you to route traffic between them. Like it's like a private connection between them. Okay, can communicate with each other as if they are within same network. Okay, and you can also create a VPC peering between your own VPCs or with a VPC in another AWS account, even in another AWS region. Okay, because that is known as inter-region VPC peering. So the correct answer here is create a VPC peering connection between VPC test 1 and VPC test 2. Why other is not correct, that we'll see. So create a VPC gateway endpoint for each EC2 instance and update the route tables. Now why this is incorrect is because you cannot create VPC gateway endpoints for EC2 instances. These are used with DynamoDB and S3 only. Okay. This we have discussed in previous videos also. Then attach a virtual private gateway to VPC test 1 and test 2 and enable routing. Now, you cannot create an AWS managed VPN connection between two VPCs. That is the reason you cannot do this. Attach a direct connect gateway and enable routing between these two VPCs. This is also incorrect because what it will do is direct connect connection to multiple VPCs. It is not useful in this scenario as there is no direct connect connection. Here, direct connect gateway is used when you are using a direct connect connection. But here there is no such thing that there is already a direct connect connection. So there is no point to use this in this scenario. VPC peering is the correct answer. So coming to the homework question. So you can just pause the video and you can just check this out, and the explanation I'll be giving it in my community tab. Why? Because this is the last video of this series. So all the very best for your exam. Study well, and if you have any questions or if you have any doubts on what topic you want to cover, you want me to cover, or you have anything specific to ask, I'm also helping people who want to gain their certification and they want some 1 hour or 2 hour of class for any specific service. So I'm also helping them out. You can connect to me through LinkedIn for any questions. Okay, so let me know how did you find the series, and please write your answers in the comment box below. Let's meet in the next video. Till then, stay happy. Let's codify with Sonal in the next video. Please like, share, and subscribe the channel. Do not forget to hit the bell icon so that you get a notification of the updated video. Thank you.